Hello, boys and girls and Campo. This is Mr. Giomini. Kind of taking a look at a couple questions from our pretest for the most recent unit because I want to kind of go over some questions that were missed a great deal by some of us. So hopefully this gives us some clarification. Because I'm looking at not next week maybe, but the following week to take the summative assessment for Unit 6. I'd like to see all of us do well. So let's take a look at some directions first. Write an algebraic expression for each word phrase. Okay, now it says write. Okay, I understand what that means. An algebraic expression for each word phrase. Now, the key thing I remember here is an expression. There is no equal sign in an expression. That would be an equation. So that means none of these will have an equal sign because, again, it's an expression and not an equation. So looking at the first one, 5 less than the product of 8 and k. Okay, less than means to subtract. Product means to multiply. Alright, now it says 5 less than. So that means I am taking 5 away from something that's already been started. So the first thing I notice is that means this, because it's 5 less than something, that means that's going to come second in my expression. The first thing is be the product of 8 and k. So I could put this in parentheses. I don't have to, but I can. I'm going to say, hey, 8 times k, because that's product. And again, I don't need the multiplication sign. When I have that coefficient next to variable, it's understood that I'm multiplying 8 times the variable minus 5. The other alternative could this be is 8k minus 5. The parentheses are not needed. I just kind of sometimes like to put them in there to show you that I'm going to multiply first. Because remember PEMDAS. Multiply before you ever add or subtract. Okay, let's look at number 2. Twice the sum. Twice the sum. Sum means to add. And I'm adding k plus 8. Now twice the sum, that means I'm doubling it. So I am timesing it by 2. Alright, now twice the sum of k and 8. Now if I just write it like this, 2 times k plus 8. Remember, according to PEMDAS, I multiply before I add, but it says here twice the sum of. So that means I already found the addition or the answer to k plus 8. So that must mean this is in parentheses because I'm doubling the sum of these two. If the parentheses are not there, it says 2 times something plus 8, which completely changes the answer. So for instance, if this is a 1 here, if I say 2 times 1 is 2 plus 8, that gives me 10. But if I take, and again, if k is equal to 1, 8 plus 1 is 9, 9 times 2 is 18. See, those are two different answers. So again, it's important that the parentheses are around there first because I am finding the sum first and then doubling that. Alright, number 6. Half the sum of 12 and t. Half the sum. So half, okay. Half the sum. Okay, sum again means to add. I am adding 12 and t. So I'm going to add 12 plus t. And I'm going to get half of that. Alright, so a couple different ways I can do this. This is similar to this. I'm going to find half of something, but I'm going to find the half of 12 and t. So that means I have to find 12 plus t first before I find. It's not to say half of 12, it says half the sum of 12 and t. So that means I have to combine 12 and t first. I can also write this like this. 12 plus t. Apologize for those. Let me kind of fix that so we can see the difference between the plus sign and the t, the variable t. So 12 plus t. And half of that, and whenever I take half of something, I'm just dividing it by 2. Okay? Let's take a look at some more problems. Directions first. Write an equation, then solve. Oh, wait a minute here. Write an equation, then solve. So this is a 2-point problem. 1 point for this, and 1 point for this. So I must first write an equation, and then I have to solve it. Remember an equation, boys and girls. If I go down here, an equation has to have a number with a variable in some capacity, whether it's b, d, c. That's going to be equal to, and then possibly, again, some other number. what I saw a lot of is number plus number is equal to variable. That's not going to work. It has to be some combination of a number and a variable, and that's going to be equal to another number. So don't do number plus number is equal to variable for this type of problem. You're going to get it wrong. So take a look at this. The world's largest cherry pie weighs 3,740 pounds. This is 7,625 pounds heavier than the largest apple pie. How heavy is the largest apple pie? Okay, so let's take a look here. I'm going to jot some notes down here. So cherry pie, I'll just call that C for now, is equal to 37,740 pounds. That is 7,625 pounds heavier than the largest apple pie. Okay, so that means the cherry pie is heavier than the apple pie. Okay, so this is I always think of this is 7,625 pounds heavier than the largest apple pie. How heavy is the largest apple pie? So again, this is the cherry pie. So C is equal to this. That is equal to 7,625 pounds heavier, or I could think more than, so that's adding to the largest apple pie, which I don't know the weight of. So if I think about that, I am going to say that I don't know the apple pie's weight, so I'll just call that A for apple. But what I do know about the apple pie is it weighs something, and if you add 7,625 pounds to that apple pie, I'm going to get the overall weight of the cherry pie, which is equal to 37,740 pounds. So now I've written my equation, so check on that. Now I need to solve it. Okay, big numbers, but definitely not something we can't solve. So, taking a look at this. I want to create, I already have my equation. Now I'm just going to solve my equation. Just going to solve that equation. So, going here, I'll write it down here. I'm going to rewrite it. I need some more room. So I have A plus 7,625 is equal to 37,740. Okay, I want to isolate that A. I want to figure out what A is equal to. So I don't need this 7,625 over here because I need to get rid of it so A is all by itself. Remember, this is like a balance beam or a teeter-totter, a scale. I want to get whatever I do to one side, I must do to the other, keep it balanced. So to get rid of this adding of 7,600, I do the inverse, so I subtract it. So minus 7,625 minus 7,625. That cancels this out, so all I'm left with on this side of the equation is A equals, little subtraction here, that becomes 10, that becomes a 3. 10 minus 5 is 5, 3 minus 2 is 1, 7 minus 6 is 1, 7 minus 7 is 0, 3 minus 0 is 3. So I now know that A is equal to 30,115 pounds. And again, to check that, I could plug this or substitute it back into my equation, add this plus this, and it should give me 37,740. And I should label this, it also is pounds. Okay, so boys and girls, that's my other point. So again, for this type of problem, I need to both write the equation and solve. So you have to have the equation, check. You have to have it solved, check. I would need to also see your work. Now again, you can use a calculator to help you out, but I want to see the steps. Let's take a look at another one. Write an equation, then solve. Okay, so I have to first write an equation, then I have to solve. So again, I'm thinking about this. Write an equation, that'll give me 1 point. Solve it, that'll give me another point. The world's largest lollipop, everything's the world's largest. The world's largest lollipop weighs 2,220 pounds, which is 10,126 pounds lighter than the largest popsicle. What is the weight of the largest popsicle? Okay, so I have to find for the popsicle. I'm just going to call it P. Alright, so let's see what I know about this. I know that the lollipop, I'll call it LOL, equals 2,220 pounds, which is 10,126 pounds lighter than the largest popsicle. So that must mean the popsicle, because if this is that, it's 10,000 pounds lighter. So that must mean the world's largest popsicle is heavier. So let's think about that. What can I do to solve this? The world's largest popsicle weighs 2,220 pounds. Okay. Or world's largest lollipop, I'm sorry, weighs 2,220 pounds, which is 10,126 pounds lighter than the largest popsicle. What is the weight of the largest popsicle? All right, let's see here. So that's going to be heavier. So I'm guessing I can take, am I going to take the weight of, let's see here, I am going to take the weight of the popsicle, which is unknown. I'm going to subtract from that the 10,126 pounds that it is lighter than the lollipop, and that's going to be equal to the lollipop's weight. So now, because I know I have to subtract to solve this, but I want to do the inverse to actually, I subtract my equation up as subtraction. But in order to solve it, I really need to add these two numbers, because this is the weight of the lollipop. This is how much lighter it is than the popsicle. So really, to figure out the popsicle, I have to combine these. But in my equation, I'm going to do the inverse of adding. I'm going to subtract it. So if I take a look at this to solve this, I would take P minus 10,126 is equal to 2,220. Okay, I want to isolate the P. I want to solve for popsicle. I don't need this 10,000 over here. So to get rid of it, I do the inverse. I add. So I add to both sides. That cancels out. I'm just left with the P. That gives me 6, 4, 3, 2, 1. That tells me that the world's largest popsicle, so then we have P is equal to 12,346 pounds. That is one large popsicle. Okay, hope this helps you out. Again, I've written the equation, check. I've solved it, check. 2 points, hopefully I'm getting those 2 points. All right, take care, boys and girls.